Hello, ladies and gentlemen. So what we want to do right now is talk about this last example. This is the projection of PQ onto N. This is going to answer questions like this. Determine the shortest distance, sometimes just called the distance, from a point to a line. And it's called the projection method. And this is the formula for the projection method. Now what I'd like to start off with is proving the formula. The formula, I don't want to just give you something out of the blue and say, this will give you the shortest distance. We should know why it's giving us the shortest distance. So let's take a look here. Let's set up what we have. And again, I'm just going to do the proof for this. So I'm going to create a line, any line. Here it is. We'll make that line L. Okay, and we're going to have a point. We can have that any point Q. And I'll give that values of, I don't know, A comma B. Now, I want to determine the shortest distance between this point and this line. Now this line has normal. There are normals to this line, and I could draw one normal there. That's absolutely fine. Now there's no reason why the normal has to be there. I could move the normal and it would still be a normal even if I put it there. That too is a normal line to my line L. It just happens to be passing through Q at this point. Now the next step I'm going to do is I'm going to let P be any point on the line. And I'm going to denote it by X comma Y. So there's a couple of things that we've done here. The first thing that I'm going to do is let N be the normal line passing through the point Q and intersecting our line L at, now I'm going to give you a new point here. We'll just call that R for lack of calling it anything else. We'll call this point R, and that'll be where our normal line passing through Q is intersecting with our line. So that's our first let. There's a second let that I've put on here. Let P, X comma Y, be any point on the line L, other than R. Just because if it is R, it's going to goof everything up and we're going to get zeros as a result and things won't be so good. So, okay, so that's what we have set up. Now what I'd like to do is I'd like to connect P and Q. So I'd like to create this vector PQ. Now there's PQ. Now it's unfortunate that this axis stopped right where it did, so I'm going to extend it so we don't get confused. So that axis is actually continuing up. So here's PQ, here's N. Now notice that we've got some interesting things here. I've got a right triangle. Okay, so consider SOHCAHTOA. And I'm inside this right triangle, and if, let's say I want to talk about that angle. So I'm inside this right triangle, and if I want to talk about the cosine of that angle, it's going to be the adjacent, which is going to be QR, and it's a length, right? So it's the length of QR divided by the hypotenuse, which is the length of PQ in that triangle. Now that's just something I noticed and we just did, and that's kind of cool. Now these are scalars, so there's no problems with me multiplying through and creating QR is going to equal the magnitude of PQ cos theta. And that was just me rearranging that, and there shouldn't be any problem with that either. So that was the first thing I wanted to consider. Now, I want to come out of there and consider something totally different. I would like to consider the fact that I could the dot product. So if I take PQ as a vector, and if I dot it with n, the normal vector, I'm going to get the magnitude of PQ, the magnitude of n, cosine, the angle between them. Now I got to be careful here, the angle between them. So let's look. Here's PQ and here's n. The angle between them has to be tail to tail. So if I move n over to here, what we notice is that the angle between PQ and n is actually here. And if we do TPTZ pattern, we notice it's the same as our theta. So theta is in fact equal to the angle between them. So we have this lovely theta again. So we have a new concept that's relating some of our old concepts. Now this is pretty close, I notice. I've got a PQ, the magnitude, I got a magnitude of n and a cos theta. Well, if I take this one now, and if I do a little bit of work to it, let's say I multiply both sides by a scalar value, and let's make that scalar value be the magnitude of n. So that was me taking this guy and multiplying both sides by a scalar. That should be fine. We notice then that this is actually equal to that, which means that this side must be equal to PQ dot n. And if I divide both sides by a scalar, so that scalar I chose to divide both sides by was the magnitude of n. That's simply going to give me the magnitude of QR equals PQ dot n over the magnitude of n. Okay, so we've developed this. What is this? Well, QR, remember, is this distance. And this distance is the shortest distance from this point to this line because it's the perpendicular distance. Any other distance, if I come off that perpendicular, is going to be longer than that. This is the shortest distance. This right here is the shortest distance between Q and R. So this is the shortest, this is the shortest distance between Q and the line. It happens to go to R. So QR is the shortest distance between this point and the line. Well, we also call that something else. In vectors, we look at this vector and we call this the projection of this vector onto this line. It's sort of the same concept of a component. This vector here could be broken down into two perpendicular components. One going this way and one coming this way. This component is what we would call the projection of this vector onto this line. Okay? It's almost like if there was a light source here shining down, that would cast a shadow here. That's why they call it projection in some aspects. But it's the projection. So QR is not only the shortest distance, from the point Q to the line, but we have a special name for that, and that's called the projection of the vector PQ onto the normal line, which equals PQ dot n over the magnitude of n, which gives us gives us the shortest distance from point Q to line L. Yay! And that is the proof of this identity. Learn the identity, know the proof, and I will come back in the next video and I'll teach you how to use it for an example.